way back actually. So we just don't realize that in a very early stage. When we reach 40, we realize that. But we have to understand that as a fraternity of dentists, that is students, faculty, even the management per se, we have to try to take the science and the entire project forward for the country. So that's the motive for us. So with that being said, yeah. So with that being said, we come from Savitri Dental College. So this is the frontage of our college. Recently we had done the version 2.0, version 2.0 version of the college. So essentially, each of these pillars and windows have a Ganesha idol with something to do with dental. So in Savita, we worship dentistry. So to implement and to make sure that everyone has an awareness of that, we try to change our entire frontage to make it a temple of dentistry. So we have certain things in Savita which Sir had asked me to just communicate so that we have a slight overview on from how we have come this far. Essentially, we started off with the basic, most clinical setup, which is integrating all the clinics together, which means under one roof, one clinic, endo, perio, surgery, medicine, and all 9 faculties are available. And each student is allowed to do all procedures in the same clinic. So there's no shuttling between clinics and shuttling between postings. So essentially 3 days a week, 5 days are there for full day, and 3 days a week, 30 days are there for full days. So that also has added a factor where they can schedule their own patients. So which means Thursday, if I'm at 1 to 3 at perio, and if I have started a work and I haven't finished and I have to do a follow-up, I have to call the patient back on next Thursday again 1 to 2. So that's the common setup. Or 15 days of posting. If I miss 15 days, I have to call after a full cycle. So to avoid that, we try to integrate a full-time clinic where the students are in the clinic all the time for 3 days, and the rest 3 days they go for academic work. So third is and final year shuttle between academics and clinic. So if my patient is there, and it's a holistic setup where one patient, one student. So anything that is in the frontier of that student, that's root canal, scaling, fillings, pediatric other therapies if it's a pedo case. The undergrad does the work there from diagnosis till treatment plan to executing the treatment. And after that, if it is out of the genre, let's say it's a deep impaction or a angulated tooth for extraction, or let's say calcified canal for root canal, that goes to the PG department. So by that we are trying to improve the quality of cases that go to PG. So all the simple stuff is handled in the undergrad. PG is essentially a workflow for maturing your process, right? So that's one thing. This is a Versa clinic, Versa lab setup. So this is a digital studio where undergrads and postgrads get trained for digital work. So 50 stations here, all 50 are 3-shape enabled. Over the course of this 2-day lecture, I'll be telling how we have acquired this, and it's not over 2 or 3 years we have reached this part, it's about 10 years. So initial parts were just focusing on clinical work and academic work before we actually went hard on the infrastructure, right? So we have a full-fledged CAD/CAM lab, which with all 3D printers, all designing softwares. We have a DMLS printing machine. We have 3 or 4 millers and a metal printer as well. We have resin printers as well. I think 6 resin printers in the entire building. One thing, like Sir mentioned, I had told him, we open it to everyone. There is no restriction on usage of this systems by anyone in the college. We have set faculty who take care holistically about of each setup, which means milling machines are held by one faculty, one department per se, printers are held by one department, but they are all central centers. So we allow students to go and explore this from the first year BDS itself. Right? So that's our DMS printer on the left side, which prints metal, titanium grades also, and resin printers as well. I'm sure a lot of you have seen the facility here as well. Your college has a lot of things. Actually, your college has a lot of things, and We are here to help you integrate it and take it one step further, like to add on a few things which will make the entire circuit complete. Right. This is our surgery wing. So this is one fascinating thing in our building. So each of this is one OT. This is the panoramic view. We have 6 ORs and a separate max fax building. Our prime clinic where we have 3 setups in the college. Elite, first classic, elite and prime. So classic is for student treatment, elite is graduate treatment, and prime is post-grad faculty treatment. So which means depending on the level the patient chooses, it's like an express clinic where they go quickly and get it done. It's very similar. The faculty treat in the prime clinic. Again, part of our surgery building. So with research, over the past 2 or 3 years, they've gone very hard on research. Like I told you, initially we were focusing on academic and clinicals. Then we went into investment in infrastructure, and then came research. So over the last 3 years, we've upped our research game quite a bit, such that IITs and engineering colleges and all other institutions are coming to Savita for dental and non-dental work as well. So we have an Instron, we have a chewing cycle simulator. Most of these machines, when we bought them 4 or 5 years ago, they were the first in India. So people were thinking, why would you buy a machine which is not related to your core field? But it became a situation that we now are the center for research for major dental colleges around Southeast Asia and Europe as well. So we receive samples from across the Southeast Asian countries, and we do our analysis and research depending on their requirement, and then we send the results back as well. So over the past 3 years, from about a 10 crore investment, it has gone to 110 crore investment. The values are not important. It's about how we are using it. You can have anything basic as well, but the best way to make the best out of it is to use it to the maximum code. So you run the machine as much as possible till it wears out. That's the actual goal, right? So with that being said, let me go to the core part where we have the digital industry workshop planned for you. So we'll be having a complete overview about the planning and workflows that we have. We've divided it into some phases, which I will be explaining as well. Again, I'm Dr. Nabil and Dr. Shali. We are both prosthodontists. We are with the Department of Prosthodontics. Both of us are inclined towards the digital industry, and we also take care of the postgrads in the department. So this is our plan of action. So first phase, we are going to analyze on what the existing infrastructure in ITS Hyderabad is, and then we're going to explore in phase 2 what systems are available in the market and how they can be improvised or integrated into a system. Phase 3 is the education part, where we train you how to use these softwares and how to plan your course curriculum and all that. And phase 4 is the implement. So the last phase, we have kept it open to discussions with the individual departments on what they want, and we can answer their questions. So that will be better because it will be open. So the last phase we kept for individual department meetings, so we discuss with the faculty and make sure to answer their questions on how to do small changes but to produce good results, right? So in the phase 1, so we analyze your existing infrastructure, we see what the scope of your existing infrastructure is, and next we see what the available solutions in the market are. And then we see the suitable most combinations for manufacturing, that is essentially lab manufacturing, but we've also integrated a small part of building manufacturing as well. And what additionally you need in-house for manufacturing. And if you have certain limitations, see, it's not easy to go out and spend really high money on everything possible. So there are some things that are limitations. The best thing is to figure that out and match it up with an outsourcing project, which means, for example, if we at this point maybe we cannot get a DMLS, we get the DMLS work done outside, just the metal part, and then come back to the university and use our resources to maximize on the ceramic layering and all that. So we're going, for example, a PFM crown, or this is our intention. So we'll even give you a slight idea on what to outsource, so that with your current systems you can run the job quite efficiently. So the second phase is, I think that's a repeat where we have we're going to talk about the available materials. And so the previous phase was machinery. Then we talk about the consumables that are available in the market. That is to do with zirconia blanks, metal blanks. There's a lot of scope actually with the system that's here. We just need a few add-ons, which means it's not complete, but it's there. So the major chunk is already bought. It's a very minimal investment now to take it to the next level. So that's something we'll help you out with, and we'll talk about common clinical laboratory workflows, and the last three parts, that is how to incorporate it in the curriculum, how to incorporate postgrads in the curriculum, and setting timelines for completion of your tasks and all that. That we'll have a discussion with the faculty per se. Right. Phase 3 is the beginning of tomorrow, where we talk about individual workflows for crown and bridge, smile designing, removable dentures and complete dentures, dental implant planning, implant solutions for specific cases, and we are talking about guides for almost all surgical procedures, because digital is going more towards guided, be it for tooth prep, be it for gingectomy, be it for implant placement, be it for sinus lift. People want predictable outcomes. So one way to look forward to it is go mostly guided. So we'll give you a full analysis of that, and then we implement with a discussion about with all the departments. Right. So that brings us to phase 1. So we are here to analyze your existing infrastructure, and I have a list of things that I have received the institution that this is what we own, and we need to know the max potential of it. So you have 2 intraoral scanners, shining 3Ds. They are very good, they're very accurate as well. And you have 2 printers. I'm assuming that one is fully functional now, that is shining, and the frozen is not fully functional, but it can be fixed. And you have a CAD/CAM lab, which is with your Ceramil software, and you have a milling machine, which is Ceramotion. That's one of the premium milling machines available as of today. It has a lot of options to do pre-mill, titanium abutments and all that, but I'm assuming that from the discussion that I had with the faculty, that right now we're producing zirconia crowns, bridges in-house. But that has a potential to do PMMAs, lithium disilicates, that is your glass ceramics, and your titanium-based abutments as well. It doesn't have a full metal coping milling option, because the spindle power is a small issue, but that's something that you can outsource as well for the only metal work, which either you can DMLS it out, or you can get it outsourced for milling metal as well. Okay. Then we have a small introduction about the CBCT machine, which is technically an acquisition software. Okay. And you have a 3-shape ortho analyzer and a 3-shape implant studio as well. Studio wise, the implant studio, I'm assuming we are using it essentially now for surgical guides for implants. We decide on how we will implement that. And you have the Dolphin supplementary and the OEM software. Those are adjuncts which you can use for any other part of the dental dentistry, or to store data and to have a repository for life. So coming to the individual ones. So the key applications of your shining 3D scanner, essentially for any scans, any intraoral scans, you can have crown and bridge, inlays, onlays, veneers, scan, orthodontic models, and the shining 3D system actually comes with a lot of additional features in the software. I have a system here. If someone can turn it on and give you a slide demo, but I have videos as well for how to deal with that as well. So it has it can capture scan bodies, it can generate patient data as well. So which means essentially you can scan an upper arch and a lower arch, and then with the click of a button you can actually analyze the system itself will give you a report on where the dental caries is, where the bone loss is, where the calculus is present. So this can be shared with the patient as well. So this is how the report actually generates. Otherwise the scanner has the main function of scanning orientations. So there are certain limitations to it. I'll tell you how to overcome that as well. So this is your health report that gets generated out of the Shining 3D software, where if I, okay, I'll do this on a one-on-one demo, so that will be easier. So this is a complete overview of the patient where it can give you a solution on which tooth is caries, which tooth has periodontal problems, which tooth has calculus, and all. This is just one click of a button in your existing software. So you can generate this for all patients who are coming in, especially the ones who are coming to Express Clinic, because I'm sure that they want to have a better understanding of their treatment plans. Right. It also has an auto simulator option. So if you choose the auto mode scan, to convince your patients, you can actually run the auto simulator to get them agree to treatment. So seeing is believing. That's one thing. See, the intention here is also to improve the clinical practice. So right now your postgrads, you will go out and you will be practitioners later. And as faculty, I'm sure we have a practitioner setup as well. So to maximize both outcomes, a deep dive into every software is absolutely necessary. So for example, the iPhone has so many things, but we use it for messaging, WhatsApp, phone, and probably pictures and all. So it's got a zoom in lens, it's got a pro lens, it's got features of AI, it's got Siri to help you with anything and everything. So the best way is to explore is actually just sit with it and meddle with it. You don't have to worry about what outcome is going to give you. Meddle with it and click every button and see what happens. So from the oval screen, there will be a lot of options where you can generate an AI report. And also the Shining 3D itself can design crowns, single crowns alone. So if you are an endo PG or endo resident, you can design your crowns immediately after you scan. And if you have a well-integrated printer, you can print and deliver within like about 1 or 10 at least. Right? So that is possible with the Shining 3D system itself. Next is your, please feel free to ask questions. Yes, ma'am. Yes. Yes. Can we connect this to the main screen? If someone has been using this for scanning, can you come up and tell me which case is what, if you have a single or three refresh? Anything with single counts? Okay. Single count. So, restoration. Yes. That's what I'm getting into. That's okay. Okay. So, okay. Okay, so this is how your output comes in. Okay, and here you should have an option to Or a track? Yeah, because there are no tracks. Right, there are no. Right, right. Actually, there's a small thing. I think this is the software has been upgraded because there are a lot of options that are on the AO3 is missing actually here. Let me check. No, 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 no. The AO, you just have to upgrade the software for the shining tree. So they are usually here. Okay? And there should be a last additional option which will give you the crown designing features. You will have to contact a dealer. They will come and give you a update on the software. It can, yeah. See, actually you can download it and do it yourself. But it's better that if the dealer or the technical person does it, so that he integrates what you need. Essentially, he doesn't have to come here itself. You just have to give him a screen viewer option, and then he can do it from there itself. So here I can show you on my screen. Settings. Here. No, this is a mill map. These are for visualization of undercuts and all that. That is with every system you will get. What I am talking is additional features of AI where this is a fill hole thing, which means if you have missed a area of scanning, if you press this button, it will fill the hole. The tools I am actually insisting on are actually separate completely from this. So these are for erasing, rescanning and all that. To take this scan to a design mode or a patient generation mode, it's a little different. So on my screen I have a small tab which I will show you, which you should be seeing with a new upgrade, and you can run everything on it. Right. So this is on the right top corner you can see a small checkered box, right? So that should be available, and that has the patient report, it has the ortho simulation, everything. It's just a click of a button. It's not too difficult to do that actually. When was this procured again? Shining 3D? 2 years back. Yeah, then definitely there's an upgrade. Then definitely there's multiple upgrades. The latest one has a lot of features.
I just need to ask one thing.
Yes.
Currently, how we are utilizing the scanner is we scan it, we analyze the undercards, whatever
Right.
the clearance is there
For reprep. Right.
Then we export it to the CAD/CAM lab or the outsourced lab,
Right.
whichever procedures we have planned.
Right.
So, are you talking about chairs and designing them?
Yes. Yes.
Options currently?
No, it's possible. It's the same scanner that I have assigned to another clinic recently. You just need a software upgrade. It's just, the machinery is the same. The machinery that you're using is the same. The same scanner.
Is complementary to the
Yes,
scanner,
yes.
or is it all chargeable?
No. The softwares are almost always free for scanners per se. Designing softwares are chargeable, which means if you have an exocad with crown bridge and implant module, if you need a surgical guide module, you need to pay for it. But the software, the scanner comes with the package. Essentially, you can just go online to Shining 3D's website and download it and install it yourself. But since that little loop is missing with us, we have an IT team who is designated for this, who contact the manufacturer or the dealer who has dealing with us, and then they let them know, and they go on TeamViewer and connect it. It's a one-day thing. It shouldn't, and I'm sure you have looked at this on Dense Pro. right? So I had a word with him as well, Dr. Mr. Uday from Denslow. You can just connect to him and he should be able to update you. It's over a few hours. It shouldn't be too much. Right. So this is why I was telling, explore every option. So press every button to know what is available and what can be done next. Right. So the next thing is your printers. Your printers are quite good, especially shiny 3D printers, very accurate. For anything to do with study models, surgical guides, orthodontic models, provisional restorations, splints and occlusal devices, and your patterns for metal casting. So which means if you're not actively doing DMLS printing in-house, you can always go ahead and print resin patterns from your printer machine after the CAD design. Do the resin pattern in the printing machine and then you cast it. I'm sure the casting lab is well equipped right here. So that's one option, and one thing we would recommend is get multiple trays. Don't use the same tray, clean it up and put the second resin. It becomes really messy. Second thing is that keep a separate isolated room for printing and post printing, which means with dust in the resin, a lot of the photo optic properties are gone. So one layer won't be printed. So that is a very big thing. So for model resin, we keep one specific tray. If it's a high production system, we will keep one printer for one material. So which means one machine is only doing model printing, one machine is only doing temp printing, one machine is only doing your surgical guide printing. And surgical guide, usually we keep a separate machine because it's a biocompatible material and these are not. So you can actually mix up, you can use the other resins together in one machine, but surgical guide definitely better to use in a separate machine. Yes, ma'am. Yes, only thing is that you will have a lot of spillage with your resin. Every time you have to, let's say you get 10 tanks for like 10 resins, pink resin, white resin, castable resin and all that. Only thing is you have to keep actively using it at least once or twice every 3 days. Otherwise the material in the composition in the material sediments come. So there are photo optic sensors, there's the resin, waste resin, there are fillers, all of this has to keep shuffling. So it's difficult to pour the entire resin back into the bottle, clean it up and use another resin because that is cross contamination. Definitely no. Do not use same tray for two different resins. Yes. Now only problem is if you are using model printing and castable resin printing, then make sure you use it on a frequent basis. Otherwise, you print only what you want. Let's say you're doing more of model printing, just keep it for model printing. If you're using castable resin once in a while, let's say once in a week, then don't attempt to get a separate tray and keep a separate tank. Outsource it. Outsource that little bit part and get it. Because if the material is stagnant over like at least 2 days, all the composition gets sedimented. So you have to again go ahead and mix. And mixing resin is one of the most difficult tasks. And manipulating it also, it gets really messy. One recommendation, like I told you, keep a separate room, it's dust free, away from everything else, away from the micromotor, away from the building machine and everything. Because when the dust, right, so that is not recommended. Because are you having errors in printing? Is one layer or something missing?
We used to have a lot of errors and we were
Okay. That has a very light kind of a sensor, which means the simplest dust particle will not give you an output. So it's always better to have a separate cubicle, let it be glass or gypsum wall or something. Right. When you use it every day, was it to use every day?
Not every day, but we use every week, yes.
Yeah, that's the thing. The resin would have got sedimented. The components of the resin would have got sedimented. So in a production lab, that's why I was insisting, if you're doing production, get the resins for the maximum production and stick to it. Until there is a requirement for a castable resin to be printed every day or every 2 days. So if you have castable work to be done in every 2 days, then you get the castable resin and you get a tray for it. Otherwise, you stick to model printing now. If you are doing surgical guides,
Unless you do it every 2 days,
yes,
better to outsource.
yes, definitely yes. Because between changing the resins itself, if one or two drops of the resin falls on the surface of the printer, which is the film where the light comes through, it gets, yeah, that's exactly the thing. So,
Second question is,
yes.
so these printers, if you buy them, they recommend their own
Resins, yes.
So is it okay to use?
Yeah, it's okay to use cheaper versions. The manipulation is difficult, which means that it gets more sticky as it goes cheaper. So it's a little fluidy as it's a little higher. So Nextent is a very good printer, but it's really expensive, around like 10-12 lakhs for a printer. But Nextent has a closed system where you can only use Nextent. So it has a tag, like a barcode on the bottle. Only if you scan that barcode of the bottle, it will start printing. Otherwise, it will not start printing. These are open systems. Previous is a good brand. So always choose middle. Don't go really high. See, one, education institution. Second, production levels. So these two things is what we need to consider. Don't go too high. Just, I have a point somewhere that's coming in my slide which says just because it's expensive, it's always not the best option. Okay. So depending on our requirement is what we need to work on. Previous is very good. Previous resins are very good. Shining resins are good. They are little pricey, but they are good for your surgical guys and all. They are really, really good. Right.
One point I would
Yes.
after 2 days, what you're saying regarding the stagnation and change of composition of the resin.
No, it settles down, so you need to keep remixing it.
Dieting or some mixing ratio is
There is a separate mixer for resins. Usually when it's stagnated more than 1 day, the indication is you put the resin back into the bottle and the bottle is kept on a machine which rolls around. The rolling of the bottle actually homogenizes the entire liquid together. This is a recommendation. Right. It's difficult, that's why I'm telling you. If you're using the...
resin is there in the days of resin more than 2 days, what
Yes.
is supposed to do with the...
You need to put it back in the bottle.
If you are not putting it back, it's not experience.
Yeah, it slowly starts degrading. That's what I'm trying to tell you. So maybe you might get lucky to get 1 print or 2 prints out of it, but it will not keep coming back in a... we're looking at long term. We're not looking to print for like 1 week. We're looking to print for 1 year. So that's what you need to keep in mind. So there are 2 types of printers essentially. One is DLP, one is SLA. Both your printers are DLP. DLPs have much faster production rates, which means SLA is more slower, but SLA is more accurate. But for all our dental requirements, including the guides and everything else, the DLP is quite close to the clinical recommendations. So accuracy is accepted, but SLAs are more accurate. So if I am planning to do high-level surgical guides, there are guides now that can be made for root canals as well. There are guides that can be made for gingival procedures and orthodontic procedures as well. So that I will try to use an SLA-based printer, right? Right. So the next that you have, infra that you have is your Ceramil Mind software. So this can, as of now, I was informed that they have the Crown Bridge inlay only software. So Ceramil is essentially from Exocad. So Ceramil buys software from Exocad and brands it as Ceramil. So the better investment will always be the main manufacturer. For example, Itsdentalmuradnagar is a milling machine. You wouldn't have heard it, but you would have heard Zubler, you would have heard Zermac milling machines. I'm sure Zermac brand is very popular. But Zermac buys its milling machines from Itsdentalmuradnagar and rebrands it. Right? So if it's 350i Itsdentalmuradnagar, it's 3.5i in Zermac. So it's the same machine. So always choose a manufacturing based company. Don't use a branding based company, which means Aman Dirbat is a manufacturing company. But the software so the milling machines are really, really good. The Ceramil motion tool that you have is extremely well fitted there. But the software that they supply is actually from Exocad. So they purchase Exocad and then they give it to you on a subscription basis. So if you see the actual, this is how your Ceramil will show. If you open Exocad, it's the same thing. Just that we written Exocad on the left bottom.
Then
Yes.
Exocad does not have the option of desktop scanning. It
No.
directly goes to the design.
No. Any Exocad is the most open system. It's the most open system. You can pull out scans, STL files from any scanner in the world, put an Exocad and work it. Because they are the ones who bought in the designing part itself. 3Shape itself, to compare with 3Shape, 3Shape is also very good. But 3Shape is more like Apple. Exocad is like Windows. Exocad has everything possible. 3Shape has the most required things possible. So there's a small restriction in 3Shape which can never be in Exocad. Exocad is a full-fledged system because it's a manufacturing-based company. They design their softwares. They make sure that everything is addressed. They try to upgrade their software. So, for example, so let's say Exocad is a new upgrade for implant bars. Ceramil will have to buy it from them and give it to you. So it's better you have an Exocad system. Right. So otherwise, so your software in Ceramil has crown and bridge, which is essentially right now being used for zirconia crowns and bridges. It can be upgraded to a pre-mill titanium metal blanks as well, where you can customize abutments, and there's a lithium biosilicate option as well. The crowns and bridges that you are currently fabricating in zirconia, if you want to do lithium biosilicate, commonly known as Emax, but Emax is actually a brand name. It's the lithium biosilicate material that you get, or glass ceramics. There is a separate holder that you need to purchase, which I have put in my presentation. If you have the holder, you can start milling lithium bisilicates in-house right now. So you can deliver Emax phones right now in-house. Right? So, no. The crown and bridge outcome will come in. It's just the material of choice. The software is for the designing software. The machine mills. The machine is right now capable to mill Emax as well right now with wet milling. You might have to get some tools for it. If you have the tools for it, great. Usually the first set of tools that they give you the machine will have it, but you need to replenish the ones that you use most. So right now you can do Emax restorations in-house with the system that you have itself. Maybe a holder might be required, which I will talk about. If you have a picture of what I will be showing, you can start like that. Right. So that's what I mentioned in the bottom. Each setup for manufacturing model in ceramide, example crown bridge model. So everything you need to buy a module, right? So always when you go for a system based for designing, one system get for all modules. That's the most efficient way to do it, right? Because these are not perishable, like your resins, like your blanks, or like your tools for the milling machine. The softwares are not perishable, so they just keep upgrading themselves. So when you invest on softwares, go for the best ones, right? Right. So your motion 2, these are the options that it is allowing you to mill as of today. So you can do dry milling of zirconia. PMMA is also possible to dry mill. I have added PMMA in wet as well, the fourth point of the wet milling, because Aman Gilbert recommends PMMA with wet milling. There's one reason for that, I'll mention that. And on the dry side, you can do wax blanks, which means milling is more accurate than printing. That we have to agree. Milling is a little expensive, but the repeats are lesser. So that's the advantage of it. So if you're looking at casting materials for finer things, let's say an implant bar, in the future, you can mill wax and do a casting. That is also an option. You can mill composite blocks in dry and wet as well. And there is also a metal milling option in your machine right now. A blank. I'm not talking about the pre-milled titanium parts, sintered soft metal. So this is from Aman Girbach. It's called Syntron. So Syntron is we know zirconia blanks, right? They are technically green blanks. Green as in breakable blanks, chalky. So there is an option like that for metal as well right now, where it gets milled in dry, and then you send it to the furnace. It goes to life size, just like zirconia. When zirconia is milled out of your blank, it is usually 20 to 30% bigger, and in the sintering process, it shrinks down to the real size that was designed earlier. And these values of the shrinkage, each blank will have its own shrinkage values. So when you do your CAM designing, that is, you nest your crowns in your software, you need to make sure that the shrinkage factor is incorporated, because one zirconia blank will have 1.24 Mostly it's between 0.22 and 0.3, which is 22 to 30% shrinkage. So when the zirconia powder is isostatically pressed and it has a shrinkage factor of its own. So if your crowns are not fitting after zirconia, if you're milling zirconia crowns, you've done a good prep, assuming that you've done a good prep, no undercuts, good scan, good import impression, design is also good, and it's not fitting, then your shrinkage factor is not being accounted for. So you can't put a common shrinkage factor for all zirconia blanks. Each blank has a shrinkage factor written in the blank itself. That's one thing. So Syntron is also a soft metal blank, which means that also has shrinkage factor. It doesn't need water to melt, so you can do crown and bridge and implant work in that quite easily. Only catch is you need a separate sintering furnace. So since the material is patented by Amangerbach, Syntron, the machines was patented by them, but there are now Chinese options available. So you can get a soft metal blank, mill out a metal, sinter it, you can get your metal from as of today. An implant restoration, a bar. Yes, ma'am.
But the tools will be same as the zirconia blank?
Yeah, because it's powder. You are milling powder only. You are not milling sintered hard metal. You are milling powdered metal only. Yes. No difference. No difference. No difference. If you bring a full hard metal blank, which I have put in my presentation where I'll be showing the actual blank in the material component of it. And I've also done a cost analysis on how much it will cost to do each of these things. Then you can choose wisely on which ones you want to keep in house and which one you want to outsource. Okay. Right. So these are your options as of today with your medication. The reason why I told you that Amangerbach recommends wet milling for PMMA or acrylics is because the spindle power of the machine is 0.75 kW or kilowatts or 750 watts, which means the ones that are for high density PMMA millings should be 1 kWA and above, okay, and the ones that are for metal milling should be at least 2 kWA and above, okay. If you run a PMMA in your machine right now, 0.75 kWA, kW, you will take about 7 hours for a full blank. But if the same is run in a machine which is 2 kWA, it will take half the time. So that's how the spindle power of a machine influences the outcome of the production. The spindle power is one of the reasons for the pricing itself. So if there is a higher spindle power, the pricing will be a little higher side, but the production is very fast. So compared to a metal blank which will mill for 9 hours in a 1 kWA machine, it will mill in 2.5 hours in a 4 kWA machine. So that's how it differs. Right. So and then acquisition ke liye you have your main pillar, which is a CBCT here. So for all your planning for implant software, anything that you want to plan, it's better to have a CBCT, including root canal endodontic assessments in very complex teeth, ortho analysis, sinus for sinus analysis for sinus lift and all that, and you have your nerve canal tracking in your airway analysis as well. So core mission before you use your other softwares. So you have your 3-shape implant planner. There is an exocad planner, exoplan, which will be showing you demonstration as well. So this needs CBCT data. That is available in house. There are a couple of FOB options available for CBCT. The bigger FOBs are for zygoma implants and facial and cranial stuff. Right. You have your 3-shape ortho analyzer. Right now, I have been told that you are actively planning ortho cases, and you are having an in-house lab for orthodontic aligners as well. For simple cases, I have been told that you are doing your aligners, which is a good thing. Slowly it will move to the complex state. That's one thing. Then your implant studio. So your implant studio is essentially for prosthetically driven implants. Anything that you want to do now, they always say, look at the final picture before you actually want to do a procedure. So you have a restoration that can be designed and you place the implant according to the restoration. So such that your forces are perfectly aligned, your implant is within the bone, within the limits of the restoration as well. And you can have a design of your restoration, and you can have a density analysis of your bone and the positioning guide and the proximity to nerve canals as well. So with your tree-shape planner, this is one report that it generates. Once you finish your planning, it generates a report. We in our college, for every single implant case, we make sure to generate this. Be it a simple single implant case or a complex full mouth case. The reason is not to use it to its only potential. The reason is to use it to its maximum potential, right? So for every single case, if you take a CBCT, put it in the software, interval scan obviously, and integrate it into the T-shape software, every single case we make a report for a futuristic approach. So it becomes more believable, it becomes more sure. There are softwares, in the same software there is option for drilling protocol as well. So it will tell you these areas are less dense, so don't go ahead with final drills, go one shot, go two shot. So that's also available in the same software. You can see a map on the implant. That's one implant, 4 sides, right? So each implant is showing how much of bone contact is it. The black stuff is very poor bone. The green is middle. The going towards the gray is denser bone. Going towards the gray is denser bone. But here we have only D2, D3 bone. So before your placement itself, you can have a rough idea on what's happening with the bone around it. Okay, so these two adjuncts, which is your own patient software, that can actually integrate STL files. So which means if you're taking an STL file out of your Shining 3D, you put it in a repository, it will be there for life. If you're designing a crown for a patient, take out the STL file, put it in that patient's thing for life, it will be there for life. So when the patient comes back in 7, 8 years for a redo or something, you'll be prepared even before the patient comes. So that's the best way to use this. Of course, case history, clinical notes, I'm sure you're already using your own software to do it. And you can integrate it into digital devices as well. Right. And you'll also supplemented, not so much scope in digital dentistry, but since you had mentioned, you can actually do superimpositions on this. So you can see. Okay, great. So that's good. That will happen over time, but the thing is that you can superimpose for orthognathic cases, and 3-shape orthopan will do that. So I think this is more an adjunct right now for you. Right. So the next part of the system is how to cluster these setups. So you have individual equipments in places. So we will cluster them into data acquisition. That's the first thing. So in your data acquisition, you can cluster your Dolphin software, that's just for analysis, for acquiring that supplemental images if necessary for orthognathic cases. You can cluster with your CBCT and impression. So this is one set for all acquisition. So to go ahead with any rigidly designing, you need to have these 3 which you already have, and you need to have outcomes of these 3. So which means you need a CBCT output, you need a interval scan output, and you could have the softwares already, which I'll be talking about next. So right. Next is for your diagnostics and treatment planning cluster. So for your ortho diagnostics planning, you can import interval scans in your ortho analyzer. You can show the patient the real-time thing. Export aligner models, which you already discussed, which you're already doing, and you can segment aligners as planned the case. With your implants, you can import a CBCT scan in the implant studio, and you can plan your implant outcomes like I showed you in the report earlier. And similarly, like I mentioned earlier, you plan your implants prosthetically, right? Restorative, what you can do is you can import with your interval scanning Ceramine software, which you are already doing for single crowns, inlays and non-lays. So that is intact. And you can design restorations with proper occlusions, and you can make sure to analyze that it's come out well. Yes. 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 CBCT. Yes. We have a machine for an extraoral scanner. Mostly we are doing it for spine designing and ortho analysis for orthopedic surgery. It's a CS3, that's a CBCT machine itself. We have a Kodak for CBCT machine, which does a facial scan as well. So you can do, yes, the one machine that is your CS latest one, 6500 if I'm not wrong, that has your facial scan and your CBCT as well. Obviously OPG and RFS are also the same machine, in the CBCT machine. So it can get it. Case stream is CSS case stream that has a patient scanner incorporated. Yes, sir. Some of the internal scanner companies have also come up with certain devices for external scanning. Earlier they had handheld cameras which you rotate around the patient's. Right. So this is since the CBCT machine itself has the scanner and the CBCT outcome diagram type, it can orient quite well. Yes. Definitely. So if you have an external scanner, like Shining 3D also has an external scanner system there. Just that these models become a little expensive when you have a separate external scanner, a separate CBCT machine. So the best option is to always try to get one piece has everything. Yes. You definitely need lab scanner. Although you have, since you're in a university, if you're in a clinic, intraoral scanners, that's it. Since you're a manufacturing unit, as a university, you have a dental lab which is manufacturing grounds and which is, you definitely need a lab scanner. Lab scanners are actually more accurate than intraoral scanners. Because there's no movement of the scanner and no movement of the object as well. So lab scanners are actually more precise for implant scanning, complex restriction scanning. I would even today, if I had an option of an intraoral scan for a full mouth implant versus a impression and a scan, I would still do impression and scan until I have certain adjuncts, which also I'll be talking about. Well, so the next is your designing and customization. This is CeramMind software you have, and you also have an implant studio software and a 3Shape. This can export outcomes and models for you in all the planning situations as well, and designing your restorations as well. Right. Manufacturing, you have a 3D printers which can actually go ahead and print anything. Your Shining 3D printer right now can print anything from your tooth temps to your castable resins to your surgical guides. Pretty much everything in the frame of printing it can do it. And your CAD/CAM milling system. If you integrate these two, your production rate is set. The only thing that right now you don't have is hard metal milling. That's okay. And you don't have metal printing, but that's also okay. Right. Delivery and follow-up, including your implant surgery softwares, your restorations, treatment, progress to your clinical records and your analyzers. You can make sure to follow up on your patients and have repository data for the rest of life. Right. So this is your current production status. That is your average units of crown bridge, as informed to me, is about 350 units average per month. And the prototype implant guys you are doing, and you doing aligner designing, and you're splinting aligners over models. So what is the scope of the existing infrastructure? So with what you have, how can you improvise? If you cluster these four situations, so you combine Shining 3D, your intraoral scanner, your CeramMind, and your CeramMotion 2, and your 3D printers. Yes, ma'am. Yes, ma'am. We have 3 milling machines, lab machines, and 1 chairside clinical machine as well. That is the Cerex for chairside, and we deliver inlays and onlays and all. Sorry, sir. Each machine, total zirconia units per month is 3,035, and we do wax millings also these machines. So we mill, wax and cast them, because we tried printing resin and casting it. It's a little flexible. So usually what happens is, rather than wasting my time on reinvesting on and recasting, I rather mill my wax and then cast it. That's much more predictable for me. Milling is always superior than printing, and wax milling will not wear out on your components. It's very soft. So your tools will keep running for at least like some 50-60 blanks. So it shouldn't trouble you at all for in that use. I have a part where I have spoken about the cost analysis. Right. So putting these 4 combinations together, these are all the fabricable outcomes that you can do right now with your system. right? That is your inlays and onlays, multi-unit bridges, you can do single rounds, lithium acetate, premium we going to discuss, then your provisionals, diagnostics, then your use splints and study models. Then when you combine these three softwares, this is your acquisition software for all digital implant planning. You can fabricate your implant positions decision. You can have a complex position plan where you have angulated implants. You can actually choose I'm sure we know about the multi-unit abutments that are available for angulation corrections. So before going to the surgery itself, you will know what multi-unit to choose for this case. So yes. So you can actually angulate your implant in such a way and angulate. So in all the implant planning, this is the processes first. Once the restoration is designed, then we place the implants depending on how the bone helps us and how it's easier, and then we try to connect both. So that's the part where multi-unit case. So you can actually angulate your multi-unit implant and see at what axis is going to get different. Would you need a 30-degree multi-unit before opening the back, or would you need a 70-degree multi-unit? Of course, there are small variations. You might have decided for 17, you might end up at 19, but that's completely fine. So and even if you use guides also are prone for errors, because tooth supported guides not much prone for error with good bone. Tissue supported guides, bone supported, usually slight error is possible. Actual rate of error, 1 degree tilt in your error in your designing is 4 degrees in your restoration. So that is the actual error. So 1 millimeter off is 4 millimeters off. So that's something that we need to make sure. Yes, ma'am. No, okay. So again, central department implantology. So every undergrad or postgrad, within postgrads, prosto, perio, oral surgery, these three postgrads place implants. All 100 of our undergrads in every batch, from the third year they start placing implants. So from third year we give them at least one implant exposure. The philosophy is a little different when it comes to clinical training in our college. So you can learn all the strokes of swimming on floor, and then you can go into the pool and you can try that. The other way is you go into the pool and you learn the strokes. So we introduce a lot of difficult situations early in the curriculum. So when it comes to moderate things, it's very easy for them. So which means that third years are doing crown and bridge, complete dentures, cast partial dentures, and dental cases in prospect. They're doing fixed ortho, very simple cases. They're doing diastema closures, which is about 4 months, 6 months follow-up. So everything is introduced there. So when it comes to actual, see, the intention behind that is not to take it away from the PG fraternity. It's definitely not. That has its own essence. If you see practices abroad, the specialists would come for a really high price at a really tough case. So it's lesser work but more outcome for the specialist. That's the model that we always plan. Yes. Because ultimately when undergrad finishes, you will have a clinic. And when the clinic setup starts, he should know at least who to call for what. Yes, we have centralized implant department. So we have, so each, every case. So there are 10 stations in the entire 10 stations. So every and it's running around the clock. So we have about 30 fellows and MS students together per year. We have about these PG cycles 6 or 7 per batch per year and 100 undergrads. Students. Initially, we started off with the faculty training the students, and now we have a Montessori system where each of the senior batches are teaching the undergrad, next batches. I have put a plan in the execution part, so that I discussed with you. Yes. From the second year BDS, we have an introduction towards basic implantology. In third year, we have something called practice management. So in practice management, every department comes in before they start their clinics. Every department comes in and teaches the fundamentals of their department for about 1 week before they enter the clinics. So it's not easy. Not that today my third day gets an implant case today and he plans this next week. It will take about a month. But in that 1 month or 1.5 months where he's going, trying to learn, trying to explore, communicating with people on I don't know what to do, because this is the umbrella that we can do that. Once the graduate finishes, you can go and communicate. You just have to go for courses. Right now in this umbrella, you can go and communicate. It may take a month and a half, 2 months also for that case to go into an actual procedure. But in that period of time, the student is educating himself quite a bit. So it's actually the philosophy that where I told you, throw them into the pool and then they start learning. It's from the diagnostic part. It's not just for the placement part. From the planning, from everything, we give the options earlier so that they are designing. In first and second MBBS, they are taught to use a 3-shape software for crown and bridge. So when the implant module is very easy for them to operate. It's not difficult because they already have a small exposure on crown and bridge, and it takes 1 year. It's not that today I have got crown and bridge, I'm expecting results in 1 month. It takes 1 year for the entire output because he's exploring, he's going and clicking on buttons, he's making errors, printing, reprinting, but he comes to an outcome. So we are at least, if you reach 80% of digital versus no digital, it's a big difference. Even 50% digital implement this is not correct. Right, so that's for digital implant planning. And implant surgical fabrication, putting these systems into work together, you can have a tooth supported surgical guide fabricated already, mucosa supported and bone supported as well, and pilot drill guides also you can fabricate, and you can also do a fully guided implant surgery templates, which means that stackable and stackables is still not available in 3-shape. It's a part of real guide software, but that's not too much to invest on. So even Exocad is integrating stackable yet. They haven't got it down yet. Yes. Which one, sir? Right now they don't have stackable. They are integrating. Yeah, they are integrating. They're integrating stackable into the same system. That's why I told you, when you go for software, buy the best. Get 3-shape, get Exocad. So because when they keep updating themselves, you'll automatically get all the updates there. Definitely Exocad, at least one station. So the reason why I am insisting on you to have both options is because it's going to be close-ended. If I'm training my students on 3-shape, and when they go out there, they don't find 3-shape, they find Exocad. They should be 50% prepared at least to explore. Right. So implant restorative fabrications, right now you can do implant abutments. There's a pre-mill blank available right now. Every company actually gives a pre-mill blank in exchange for a regular abutment now. So they don't charge you separately for that. So you can actually, for single implant restorations, you can customize your abutments and then you can mill them and you can deliver to your patient. That's why cosmetic areas and all, you can go ahead and do that. Single implant crowns you can do right now with your crown design software itself. Implant provisionals, full arch frameworks are also right now possible with your PMMAs and your zirconias, because you have a zirconia milling machine, but your designing is not available. So this is one part. So if right now your designing is enabling you to do crown and bridge inlay and onlay. There are outsourcing labs which do designing and send it back to you for milling. So you can just get the design part done until you acquire those systems. Let's say you go on and you master them completely. You can actually outsource the design part alone. Once you finalize the design, once you're happy, get it sent to you, you can do the milling. So manufacturing actually takes up the most cost. Designing is not the actual cost. So when labs make a bill of 1500 for a zirconia, 2000 for zirconia, it's double of what they're spending. So if they're spending $1,000, they charge you $2,000. So that's one way to bring down the cost to your patients, and that's one way to bring in more patients. So like I was mentioning to sir in the morning, in our college, zirconia crowns are charged at 1,000 rupees. A monolithic zirconia charge is 1,000 rupees for a patient. Initially we were frowning upon it, we were thinking it under the market, but it didn't. The patients who go for premium work are still going for premium work. No one is just saying, oh, it's less here, let's come here. The simplest example my director gave me was, there is a roadside tea stall, there is a tea shop, and there is ITC. ITC sells less number of tea, but they make more money. Our roadside guy sells a lot of tea, but doesn't actually make money. So, this is the part where he thought that we are not cutting into the private practice market. People who want privilege, private practice are still going to private practice. Not everyone is not clustering. Our OP is high. Our OP is high because the acceptance of the patient. A patient who comes for 1 crown, okay, let's just do 1 crown today, let me come back and do the rest of the bridge sometime later. He will accept everything, which is training, which is education, which is exposure. That is the value of your program. Right? Right. So orthodontic aligners application, I just want to put it around. Apart from the aligners that you are fabricating, you can also do indirect bonding trace, which means with your ortho analyzer right now, the software that you have, you can position your brackets and you can print an output out of it. It's a little flexible so that you can do IDPs or indirect bonding. I'm sure the orthodontist know about it. For the rest of the people, it's an orthodontic framework. You just put the brackets inside the, it's like a guide for bonding. So you just put the brackets inside the guide and you position it and you cure it through it. So it's as simple as that. Right. Okay. And obviously with prosper full arch, you can do intraoral scanning, CBCT, ceramils and ceramide and 3D printers to create all of these restorations right now. Even you can try to print occlusal rims. You can do tine dentures printing, which you're designing after you design, and you can do denture-based prototypes and all that. Right now, your ceramide does not allow you to do that, but with the right additions, I'm sure it should be possible to do it as well. Right. Max packs and surgical, with all these combinations, you can do surgical stents, sinus lift guides, root canal access guides, bone reduction guides, osteotomy guides, jaw relation guides. There's a lot of scope for research. If you understand that digital dentistry is very new, there is the most scope for research here because it's very new. So you just have to keep doing multiple of everything, and that itself is research. So let's say you do 100 crowns in monolithic, 100 crowns in Emax, deliver the patients, can not come. That's a research. So because you have so much of fabrication, so much of machine learning, so much of materials being used, there is a lot of scope for research here. And I've put a small part in the plan that I've discussed with the faculty. Yes. Yes, but it's a little tricky, but it can be done. With Exo plan, it's much easier. Little bit tricky with reshape thing. I will put you through someone who can help you with that. That is beyond my expertise right now, but I'll definitely put you through someone who can train you on ExoCAD or reshape itself if it's possible. That can be printed. That can be done in your design software, Ceramide, but it needs a software again. So just a small upgrade. Right. So for teaching specific, you can print your analytical models. So and your pathological demonstration models, which are CBCTs, implant simulation modules. So and then you can have teaching models for undergrads and postgrads, case presentation, and research validations as well. And one separate component is what I was telling about is research. So you can actually, with the systems as you have, there's a lot of scope for in-house research. Where your students don't have to go to a separate place to get a crown getting milled. Multiple thesis topics can come out of this. Right? You can have longitudinal treatment comparisons, which is over 2 years, 2.5 years, probably even a PhD topic for that matter. You can have personalized models and just keep working on how the population here has a different pattern, or if there's a wear pattern, how common is the wear pattern for a specific, like let's say you take 20 chewers, the patient who chew, and you do an analysis and you see the wear patterns on this specific thing. So there's a lot of data. So just a small example, it's out of dentistry, but I'll just give you an example. So there was this Shark Tank, I'm sure everyone knows about Shark Tank. This is Shark Tank US. there was a person who came and pitched in an idea about cat DNA analysis. Just a small strip, and this person went and pitched this idea where I have a package where if you have a cat, I can do a DNA analysis of your cat. You can do it yourself, home test kit, and it was about $9. The cats would be available for free in US, so you can just pick up one and you can have it from the shelter. So people were asking, why would you have this model when a cat is available for cheaper? I'll just buy another cat. I'll take another cat. So this is $9, and then someone bought it. So what happened is, after about 5 years, people invested in it. Some people bought it, and some people used it. And she sold the company for multifold $1 billion for the reason that she had data. She had data from all. She created an app. The app had data. Data is everything. Your all your social media platforms collect your data, and they send it to everyone possible. So that is one major thing. So data is everything when it comes to research, and data is something that will take you a long way. So, and with one set of data, you can have like 7 to 8 topics in mind, and you can still frame 7 to 8 research questions. That is also one way to look at it. Please. Yes. Yes.
So how do you store that data? Because in our scanner,
Yes.
after once we store it's not stored.
Right. So somewhere in the presentation I have added, but I'll tell it now. So we have local server there. We have a local server which has a very high capacity. Everything that is on a monthly basis or a 3-month basis, whatever designs we have, we ship it to the local server. The local server will have the repository forever. The second option that you can do is a cloud-based server, where you can have a cloud data. Only thing is you always need internet active Wi-Fi to upload to the cloud. But yeah, but this is really high Wi-Fi. So to upload you need Wi-Fi. To access also you need Wi-Fi. But a local server will enable you to get it anytime you want from the server itself. So we have a local server with lot of hard disks there. Every computer is accessible by a local server. So let's say I have a scanner with me and I've done 1 month and I'm running short of my computer, which is technically a device which will have like 1 TB or like max 2 TB. They have data storage. I copy whatever is required and push it to the server with the date, with the time log, everything. So I just keep doing that continuously, and I have a big repository of everything that I have. And one thing is our software as well. We have a integrated software called DICE. That data is for clinical, but for all the laboratory data and all your scans, every single scan that has been taken far back in 2021, 2022 is still available in the local server. Any computer possible, you just have to go to the local server, download that file, that's it. Right, so I have one example on how, since I've been talking about a lot of theoretical aspects on how to integrate this, I have one example where the integration actually works. So let's say this is the flow, your patient needs a, no, this is one section and then 2 slides, 2 slides, then we take over. So integrated workflow, and where your patient is an implant and a crown. So you can scan your dentition with your intraoral scanner, which is your Shining 3D. CBCT, you've already acquired your machine and you got your bone mapping done. You merge both, step 3 will be to merge both of them and you plan an implant. Export the STL and you can print the guide. Right now you can do this. And you can print the guide frozen. Place the implant with the guide and scan post-op site, and actually you can go ahead and deliver immediate right now. So immediate loading the cross-reference here will agree with me that we have about 2 days to 3 days to work on the implant once the stability is above 40, 50 plus imprints. So with this in-house software, you can actually access this. Today a patient comes in, I'm sure with the accurate workflow and that you already have, you have centering machines, you have everything here. You can deliver the crown in the 3rd day. So again, this is all possible in the machine. At least provisionals you should be able to deliver for cosmetic case. So this is your flow where you do your iOS, interval scan, 3D CBCT, that is your significant. And then once you integrate both, you can plan your implants. That's the three-shape analyzer on the fourth shutdown. Once that is done, you print your guide, and once you print your guide, you do the implant surgical placement. Put a scan body, scan the integrated design, restoration, premium abutment, fix the crown. This may take about 1 or 2 days, depending on the manpower as well. If you want to expedite the process, at least go for a premium imaging because that doesn't need any post processing. If you have a PMA blank, you can just mill the crown out of it and you can temporize the next day itself, or actually same day if possible. Right. So that was phase 1. So if we have to break now, I think before phase 2, I will break into this.